Let us pause for a moment and look back to February last year. You may remember the excitement and news about NASA's successful touchdown of the Perseverance rover on Mars. The crater you see here was a lake once, approximately 3.2 billion years ago, providing us with a glimpse of an old Martian ecosystem. This historic landing brought with it some of the most incredible visuals we've ever received from the Red Planet. Thanks to its advanced cameras and cutting-edge technology, Perseverance has captured stunning 4K images that give us an unprecedented view of Mars, immersing us in its barren beauty like never before. As the rover ventures into Mars' ancient landscape and reveals pioneering findings, it follows in the footsteps of its predecessor, Curiosity, which also provided stunning high-resolution images. Collectively, these rovers are expanding the boundaries of space exploration. But why is NASA investing billions of dollars just to snap photos? These photographs are much more than snapshots. They're instruments of science. To understand their importance, we must examine how this journey started. In the last 20 years, NASA has sent a succession of progressively advanced rovers to Mars, each step revealing more about the planet. Spirit and Opportunity took the initial voyage in 2003 and were sent in a search for proof of water. Their data implied that there may have once existed on Mars conditions that might have been life-permitting. Next was Curiosity in 2012, which revolutionized our knowledge of Mars by landing in Gale Crater and transmitting high-definition images and crucial scientific information. Its purpose was to examine the Martian geology and climate and determine if conditions were suitable for microbial life. In 2021, Perseverance arrived with even more advanced equipment, tasked with searching for signs of ancient life and collecting samples to be returned to Earth in future missions. Through the lenses of these rovers, we've received an extraordinary visual and scientific exploration of Mars' landscape, geology, and climate history. The story of Curiosity is a testament to human ingenuity. It was launched on November 26, 2011, from Cape Canaveral aboard the Mars Science Laboratory mission. It traveled 560 million kilometers, approximately 350 million miles, and landed successfully on August 6, 2012. It landed in an area called Elis Paulus, near the base of Mount Sharp, a 5.5-kilometer high mountain within Gale Crater. This crater was selected since signs indicated that water used to flow there, making it the perfect location to examine the possibility of Mars sustaining life. The mission of Curiosity was centered on examining the climate, geology of Mars, and the availability of major elements such as carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, all of which are essential for life. The rover examined biosignatures and biomolecules that might indicate previous biological processes. It analyzed the chemical, isotopic, and mineral content of Martian soils and rocks to learn about the surface-shaping geological processes. One of its most important instruments, the ChemCam, employed a laser to vaporize samples of rocks and examine their chemical content, uncovering the past history of volcanic activity and Martian water. Curiosity also probed the Martian atmosphere today, specifically the water and carbon dioxide cycling, to see how the climate evolved over billions of years. That information is crucial to understanding Mars' evolution from a potentially warm and wet planet to the frigid, barren world we know today, and could assist in the path toward human exploration or even terraforming in the future. Radiation was also a significant issue. The rover was equipped with instruments to detect galactic cosmic rays and solar radiation, giving vital information on the dangers future astronauts could encounter. In 2013, Curiosity made a historic find, proof of an ancient streambed in Gale Crater. It also discovered clay minerals, which can only be formed in the presence of water, further supporting the theory that Mars had once been habitable. Curiosity's detection of variable methane in the air has fueled debates on whether or not the source might be biological or geological. Its powerful camera systems have enabled us to behold Mars as never before. Enormous rocky plains, wind-carved shapes, and towering mountains in stunning detail. Perseverance is now clearing the way for the space exploration of the future. It took its initial test drive on Mars on March 4, 2021, leaving behind the first pair of wheel marks in Martian dirt. In addition to exploration, the rover is caching samples of Martian soil, rocks, and atmosphere to return to Earth in the Mars Sample Return mission. Its discoveries include cryptic leopard spots on rocks from Mars, the sort of markings that could have the potential to teach us things about ancient Martian life. This mission has also motivated millions of people worldwide. NASA's Send Your Name to Mars initiative enabled more than 10 million individuals to send their names inscribed on microchips carried by the rover. Perseverance also paid tribute to frontline healthcare professionals during the COVID-19 pandemic with a special plate. Its parachute even bore a secret-coded message, "Dare Mighty Things," a strong reminder of NASA's bold vision. Among the numerous images Perseverance has returned is the classic Octavia E. Butler landing image of February 2021, depicting the plume of smoke from its descent stage as it landed. The rear hazard camera gave a close-up of the terrain, assisting the rover in navigating safely across the Martian surface. On Sol 213, parachute and backshell landed resting on a ridge 2 kilometers away from where the rover sits now. Mars' classic red landscape in stark detail appeared first in full color, then panoramas disclosed vast vistas of its rocky, foreign terrain. Both Perseverance and Ingenuity, which is its attached small helicopter companion, have traded visuals. A single photo from the Mars Reconnaissance Orbiter looks down on the rover, and mutual photos show the helicopter and rover taking each other's pictures. Maybe the most historic event was when Ingenuity made the first controlled flight on another planet in April 2021 at a location known as Wright Brothers Field. In August, later that year, on its 11th flight, Ingenuity saw Perseverance from the sky, providing a novel bird's-eye view of the rover working. Another stunning photograph, the Van Zyl Overlook, provides a stunning panoramic view of Mars' hilly terrain and rocky outcroppings. Ingenuity has also recorded video and audio of its flights, broadening what we know and experience about Mars. These achievements not only represent a milestone in what we know about the Red Planet, but also encourage future generations to dream big, explore far, and dare mighty things. Butler landing photo, taken in February 2021, captures the moment Perseverance touched down on Mars. The smoke plume from the descent stage is visible, marking the rover's safe arrival. Another image from the rear right hazard avoidance camera provides a clear perspective of the terrain, helping the rover avoid obstacles. A captivating image taken on Sol 213 shows the parachute and backshell lying on a ridge about 2 kilometers north of where Perseverance now rests. The first color photo taken by Perseverance offers a vibrant image of Mars' surface, showing its reddish terrain, rocks, and dust. A panoramic shot taken on Sol 14 provides a sweeping view after Perseverance's first long drive, revealing the vast, rugged Martian landscape. Other images include an aerial shot of the rover from the Mars Reconnaissance Orbiter and reciprocal photos of Perseverance and Ingenuity capturing each other. One of the most significant achievements in aerospace history is the first controlled flight on another planet, which occurred when Ingenuity took